Hello everyone, and welcome in this new Nervland Devlog session number 21. We continue today with more native symbols from WebGPU. Last time we just made a review of the triangle symbols implemented in with STL2 and the two cubes symbols which actually was rather three cubes. So in this part we've seen the implementation of the bind group builder and the render bundle builder, and now we continue with the next symbol here, which is about bind groups. In this one, yes, I think we really need to mention the texture loader with the support for KTX, which is an interesting format if you think about it. So let's see if we can give some details about that. So the symbol was bind groups here. Again, from now on, all the examples that I'm building them with STL. So we're always using this STL app context. Proceed as usual, basically. All those symbols are built with the same structure in the end, at least so far. And there is a first step where we'll need to prepare some buffers. So we have this function here. We're going to create a camera. We're going to use as in the previous samples the target camera controller, and then we have the setup app function, which is the main function where we're going to do the preparation of the pipelines that we need to do the web GPU rendering. So what we have here, which is already pretty new, is this loading mechanism from glTF. So I have taken the implementation that was provided in C and tried to kind of encapsulate that into C++ interface mostly. Actually, I've been working on it and modifying this significantly in the end. So if you just have a look at the cube glTF, I think we have that. Let me see. Assets, model probably, test, and cube. So this is in fact just a simple JSON file, and you have the possibility to embed some binary data in there, in the base 64, for instance, here, or you can link to external data files. Usually you would call that bins, something bin, or even directly textures or images, so JPEG or PNG, for instance. I think you can link that also. But anyway, in this example here for the cube, it's a pretty simple and very minimal file, in fact, and you're just going to define simple mesh. In there is only one primitive. You have some attributes for your primitive, indices also, and a specific material. Actually, if you're not familiar exactly with how this glTF format is working, it's a bit tricky, I guess, at the beginning, but if you think about it, it's not that complicated, because those attributes, for instance, position here is pointing to the accessor 0, which is the first accessor in the list here, so this one. And this one is itself pointing to the buffer view 0, so that's going to be the first buffer view in the list, so this one. And so this one is pointing to the buffer 0. So if you go into your buffers, you have the first buffer here. And you see that all the views are actually pointing to the same buffer, but with different offsets So the first part is going to be the position, for instance, and the second part is going to be, I don't know, the normals, and then the third part, the texture, and then the indices themselves. Everything is put together in a single buffer here. So the implementation is just going to try to read this JSON file. And in fact, this part I'm not doing myself because I'm using the glTF library, as far as I remember at least. So let me just try to go a bit in the function itself. So when we are about to load this file, so we have a dedicated glTF loader with a static function. And yeah, you start to see some of those glTF elements. So you're going to do the parsing, and this is going to fill this data structure, which is pretty big as far as I remember, because this gives you access to all the components that you may have in a glTF file. So you have all the meshes, materials, the buffers, accessor, textures, and everything. In fact, the scenes and nodes also. We have nodes in there. Yes, that's node. Yes, and so on. So the goal then was to use the structure where you have your model loaded in memory, and to try to build something that you can use in WebGPU. So yeah, I'm not going to go into too much details in that. I just try. So you start with loading the buffers in memory, then you find yeah, that's my own representation of what a glTF model is going to be. So we start with adding some scene. We may load texture samplers and even load images this way, then load material. I don't think this one is implemented yet. It's to be done. Loading the mesh themselves, this one is implemented and pretty complex in the end, but it's working fine now, because if you try to just use the data from the glTF file directly in WebGPU, the format is not really the most appropriate structure, because you have elements all over the place, and if you rather want to start building something at least a little bit optimized in WebGPU, you have to go with pipeline centered implementation. So the idea is really to try to change your pipeline as less as possible. So you don't want to have so many pipelines, not one pipeline per sub mesh or something like that. So if you can share the mesh structure between multiple mesh, if you can share the materials and stuff like that, you have to try to do that and use only one pipeline, for instance, to do this. So it's a bit tricky to get the proper structure, but I'm working on it, and this is still a work in progress, I guess. And if we go in this model, then so we see we have a few functions like adding a texture, adding a scene, adding a mesh, a node, and then these are the key element. When you try to get a vertex buffer object or index buffer object for a given, well, vertex format, in fact, yeah, that would be tricky to go into this. So let's just say it's magic and it's working. But yeah, maybe one day I could go into more details if there's an interest in that. Anyway, so this was a big part, actually, the support for glTF loading, and it's not even the first thing that I mentioned here. It's a second line where I define, say that, yeah, I have support for glTF, at least to support loading nodes, meshes, primitive and scene, and in fact images also, right? What do we do? We load images. Yes, we may have a path to a texture image, so we're going to use our load texture from file function here, or we can just try to load the image from memory. I don't think those functions will support any kind of texture format. I think this one, for instance, if you're trying to load from memory, it's relying on the STB image library, as far as I remember. Yes, so you can't expect to load KTX, for instance, this way, but generally speaking, for a starting point at least, that's fair enough. So yeah, eventually you get a model here. You can get the vertex buffer object for this format. This format here stands for I for information, I would say, then P for position, then N for normal, and U for texture coordinate. It means that this is exactly the kind of data that you can expect to find for each vertex. So you get the vertex buffer, the index buffer, and here we have the support for loading those KTX file. Load texture from file, and it's going to use, if it's KTX, a dedicated path here, and this will rely on the KTX library, which is integrated into this the project now. Again, probably not worth going into too much detail on that. This is a pretty low-level function, so it's half coming from the C implementation and half, well, re-implemented with some changes in how you do the logging and stuff like that, for instance, to get that integrated into my own engine here. But the good thing is, it's still working fine at least, and we can get the images to load properly. So let's just try to run this example maybe. That's WGPU, bind groups. Not even sure it's still working, but we'll try. Yeah, working. So it's a similar example to the previous one, which were the three cubes, except that this time the cube here is loaded from a glTF file, and the textures that we see are loaded, each of them, from a KTX file. So demonstrating both new components at the same time. Alright, let's just get back to the file, the main file here. So we're build loading the texture, then what do we do? Preparing buffer, blah blah blah. Bind group. Add uniform buffer, that's going to be for the camera data. Then we had the simpler. We add then another bind group, per model binding. Okay, that's going to be just a model matrix, and we add a fragment texture per model also. So this is really just to define the two bind groups, so defining the layout for those bind groups in this builder. Then this builder is aware of what is the bind group layout for the group number 0 and what is the layout for the group number 1. And what do? We build a group for the index 0, so this one. So we're going to provide a uniform for the entry 0, so this one, and then a simpler for the entry 1, so corresponding to this location. Then we do the same thing for the models, so model 1, 2, and 3. we're going to build the group with index 1 in the free statement here, and then we provide the uniform buffer, which is going to be the model buffer here, but we may have an offset depending on where we want to connect this buffer exactly, not the same location depending on the model. That's still not the dynamic offset, right? Yes, there was another example for that. And then we add a texture. So in the first one, we have the texture 1 view. And for the 2 next cubes, we're using texture 2. So the 2 next cube are the cubes on the left and the right, while the first one here is a cube in the middle of the scene. And then we are going to build a pipeline using the code from this file, render pipeline. So we use the same code for the vertex and the fragment shader construction, except that for the fragment we're going to change the entry point to be the main fs. So if we look at this file, we're going to see the two functions, main for the vertex and main fs for the fragment. Here it's business as usual. Basically, we use the projection, view matrix, and model matrix to transform the input position, and we are forwarding the texture coordinates here as chords into the fragment shader. Then we use those chords here to sample the texture that we have provided. And so this is defined at the beginning. Group 0 is for the camera data, and then still in group 0 we also have the sampler, but on binding 1. Then we have the group 1 where we provide first the model matrix, model buffer, just containing this matrix actually. And by the way, it would also work if you were to just use this directly, for instance. Well, except that then you would not use model matrix, you would use model directly as a matrix. But yeah, let's just not do that for now. And what else do we need to mention? And yes, binding number 1 is the texture 2D that we have binded in this group 1. Okay, and for the vertex buffer, we have the location, position, normal, texture, location, what did I say? Information flag. This is just a U32. I'm not quite sure. On the long run, I'm going to keep this. I thought that maybe I could use that to provide some per vertex flag or index or whatever, but yeah, it was not very clear from my perspective, and so far I have not really been using that, so not sure yet. Anyway, so we build the pipeline and then we build a render bundle. What do? We set the pipeline, set the group 0, set the vertex buffer, index buffer. Yeah, sorry, so I was saying we set the vertex buffer, the index buffer, and then we set the group, which is different per model that we want to draw, group number 1, and we request a draw indexed call, because this time we have indices for this model, because this model is coming from the glTF file, and in there we had those indices. I think we have seen that already, so don't need to show this again, I guess. And when we're done with that, we generate the bundle, and we can add the bundle to a render pass. So just requesting to execute this bundle every time, and that's it. This is then what we're already doing in the previous example. So good. this is it for the texture loader support and glTF support. Then we had another example for the dynamic uniform buffer, and this is where I started to provide this render node implementation, which is something I've been using since this point, and I feel that it's quite convenient to encapsulate the construction of static elements, at least. So let's just have a look at this one. Dynamic uniform buffer. Let's see. So when we do the setup this time, we're still going to use this cube. We're still going to use the same texture, in fact. And this is where we start building this render node. When I ask, for instance, to create a render node with this vertex format and this shader file, then it's going to prepare the pipeline internally. For each render node, there is an internal pipeline which is constructed. And then for the render node, you can add a bind group, but the binder here, this structure has changed a little bit also. We have now this define group where you can pass well, as many parameters as you want. In fact, this is template function, and you just define all the elements that you need for your group to prepare the layout for this group. So this is the group number 0 when you do define group here. The first element is going to be a uniform buffer, because you're just providing an integer value, and in this case it's assumed that you're going to link to a uniform buffer. So it's preparing a uniform buffer in the bind group layout. Then we have this def simpler, which is preparing a simpler binding in the layout. This is just a simple structure. Actually, it's empty, but the fact that this is provided as a type for the argument is what we use to be able to construct the group correctly, the group layout. Then we have another group layout definition here where we define a uniform buffer object. This time we provide the size, but we have the true here. It's similar to what we were doing here. Internally, it's probably going to build a def UBO, but this would be set to false by default, and I think this one is for the dynamic offset definition. If we go there, yes, size, and then the dynamic flag. So what we are going to tell the system here is that the bind group that we are defining here will have dynamic offset for the first element in the group here, which is going to be a buffer binding. So once we have defined those two groups in the binder, we can actually provide this binder when we construct the render node, and then the render node, when we do add bind group, it will use this binder to actually instantiate a bind group using the layout 0 in this case. So we provide the uniform buffer, the actual uniform buffer, and then the actual, not quite actual, it's just an enumeration flag here, but it's going to construct a linear simpler under the hood for this bind group. Then we add another bind group with the index 1, so using this layout, where we bind a UBO with the model buffer, but we have an offset of 0 in this case, the size, and then Yes, a texture 1 in the first case. Then we create another bind group, again using the layout 1, where we again provide this matrix, this buffer, but this time with texture 2. So, in fact, you see we're binding the model buffer directly for both bind groups here. But this is where we start using those dynamic offset then. So when we do then add drawable, provide the vertex buffer and the index buffer. So we're requesting here to draw 36 element from this index buffer. And then we have 0. What is 0 here? Yes, I think that's to indicate that we're going to use the group layout 0. So this one is 0, this one is 1, and this one is 2. So we link 0 in the first group binding slot. So we link this. And then we link dynamic binding, which is a binding 1. So it's this one with a dynamic offset of 0. So just directly this one. For the second model, we do the same thing. We link 0, which is this one. Yeah, one thing I need to keep in mind here is that the index 0 here is definitely not the same thing as the 0 we have here. 0 here means it's the first one you create here, actual bind group, whereas 0 here is meant as it's the first layout available in the binder here. So yeah, still a bit tricky to understand it if you're not familiar with that yet. Anyway, then we are going to again provide a dynamic binding using the bind 2 in the list. So this one, and you want this time to provide an offset of element data size for your only buffer where you have a dynamic offset. So it's going to be applied to this buffer here. So this value is applied to this buffer because it's defined as a dynamic buffer. Pretty tricky. And the last model again is the same thing, except that we use twice the element offset because you want to jump to the next model to draw. And with that, you have a render node, and you can request to add a bundle created from this render node. And when you do that, with all this information, the render node itself will create a bundle and will add the corresponding bundle to this render pass. So yeah, everything is starting to get a bit encapsulated now with this render node mechanism. After that, what do we have? We have the update uniform buffer, where we're going to update the camera as usual, and also the model matrices for the cubes, so you're making them rotate a little bit. And this is then business as usual. So let's just try to show this again. Basically, it should display the same thing as the bind groups symbol, but this time we're using render nodes and we're using dynamic offsets. So it's dynamic buffer, or I don't know, it's just the name I'm using. Dynamic uniform buffer. Yes, it is. Oh, a bit more cubes than I was expecting. Really? Wait a second, there's something. What is the number of cubes? Three. Are you really talking to me? Okay, oh, maybe this is not the source I'm using anymore. I might be using this one, version 2. Version 2, we have a cube. What about the number of models? Yeah. That's probably steps on the row. 15. Number of object is 15 by 15. So this is what we see, right? 5. Yes. Okay, so that's probably what we are actually building. We can check that here. And yeah, first version was with only 3 cubes, but the next version I did was with I don't know how many, so 15 by 15 cubes. What else do we have different in there? Apart from the fact that we're changing the number of cubes, I don't think there's much changing here. Well, we're using the same texture for all the cubes. And so we define 2 layouts again, but then we define simply 2 actual binding groups here, because we only have this single texture now. Get align element size. Yeah, we need to take into account this 256 bytes alignment requirement. Then we add a drawable for each object, and we do this dynamic binding using the appropriate offset in the model uniform buffer. Right, and then yeah, we just add a bundle again with this render node. For the update of the uniform, it's the same as before, with a slightly more advanced mechanism to do the update of different model matrices, but that's all. And so here we go. And again, the recording is 32 minutes already. How could it become so long so quickly? And I've just covered those 2 examples. No, that's 3. Only those 2. Come on. This speed, we will still be here tomorrow. Anyway, I should probably stop here and we'll continue with another session then, because otherwise it's way too long. So thanks for watching, and if you have any question anyway, let me know. Bye bye.